Hey everybody, this is Larry. This is day 21st of February. Leetcode daily challenge, all that stuff. End of third week, yay! Hit the like button, hit the subscribe button. Join me on Discord. Let me know what you think about today's problem and also the two contests. I don't know if you did either of them. Let me know how you feel. I did I think I did 60 on one of them and 300 and something on the other. But the theme recently has been just weird Python performance. Like I spend more of the time worrying about whether Python can be performant more than problem solving, which is kind of not a good trend if you ask me about Leetcode. It's been doing this about the last month or so. I don't know. Anyway, getting back to today's problem, broken calculator. Okay, let's see. So yeah. While you're here, hit the like button, hit the subscribe button, join me on Discord. Or maybe I already said this, I don't know. Maybe I am also like a broken clock. I got nothing. Okay, anyway, let's take a look at the problem actually. On a broken calculator, there's a number showing on this display. We could perform two operations, double or decrement. Okay. Minimum number of operations displayed by. Okay, let's see. So we start with X, we want to get to 3. And we could use either of these things as many times as possible. Okay. XY. The min is interesting because so you can always do the answer by keep on doubling this number and then subtracting, right? Is that good enough? So there are other routes, right? For example, yeah, like this one. You know, if you just go to 3, 6, and then 12, then you decrement twice, that's not good enough. So, So, okay, so let me think about this, right? So given the numbers are 10 to the 9, we have to at worst double 32 times, right? And then within those 32 times, and I think the number of doubling, I'm solving this live, so if you're wondering why I'm struggling, then that's probably why. Feel free to fast forward or skip to the head. That's just my warning. But okay, so I'm trying to make some justification of playing around. If this is odd, okay, if this is odd, then what does that mean, right? I'm trying to figure. So I have this idea in my head where we try to go from 5 to 8, and then we try to go from 5 to 4 and so forth. Obviously every time we do that. And the reason why we can do it is because that's the equal to x divided by 2 at a certain point. And basically we're trying to go over it, but without by that much. But I'm trying to think whether that's good enough, because that's a little bit greedy, and I don't know if it's exhaustive enough. To be honest, I don't have a good confidence about that. So let's try it. All right. Let's try best is equal to some infinity number. People have told me to do this, so let me do this just to be consistent. Return best at the very end. Actually, yeah. So then now we go while y mod 2 is equal to 0. So we start with steps is equal to 0, but we also do divided step is equal to 0. So I hope that, so I don't know that I didn't explain this part very clearly, but what I'm trying to do, and I'm just playing around right now, which is that for each y, we try for 8, we try 8, 4, 2, and then 1, and then use greedy on one of each of those. And the reason why we can divide this by half is because that's equivalent to x multiplying by 2 later, right? that's basically the idea, and then we could brute force on that. So yeah, so yeah. So while this is equal to 0, we we could write greedy calculate x y. So this is okay. Let's do steps here. So yeah, total steps is equal to steps plus this greedy thingy, and then we mod by 2, increment by step. Oh yeah. Oh no, whoops. This is divided by 2, of course. And then now at the way end, when this is odd, we just do it one more time. We go total steps is equal to steps plus greedy calc xy, and and we have to do a best check, right? Best is equal to min of best total steps, and we also do that here after doing this. And I think that's the look that I have right now for the greedy calc with x y, and again this is just doubling x until it gets to bigger than y, and then to get the difference, right? So while x is less than y, we multiply by 2, we do steps increment by 1, and then at the very end we return steps plus x minus y. I think that's my idea. I got something in my eye right now, so if you see me rubbing my eye, that's why. I don't know how to prove this, but I think it's going to work for the test cases, or the example test cases, because if it didn't, or if I didn't think so, I wouldn't have written it out. Man, I got something in my eye. So that looks good. Let's give it a go, and let's get a wrong answer, and then see if it's wrong then. Okay. So why is this wrong? Maybe I don't know how to do this, but 39 seems like a much smaller number than what I was thinking of. Sometimes with these problems, I definitely need to play around with them to know, as you can kind of see. But, how do I even get this answer? Because wouldn't this just go to, I guess y is just something, I guess the first y number is something really small. Oh. Yeah, y goes to this before it's an odd number, and then what happens? And then we keep on doubling 1 until it goes bigger than this, right? So what I'm thinking right now is just try to think about a smaller case for which I get the wrong answer. So I think maybe someone like, it's some odd number that's like 1517, something like that, that would give me a wrong answer, I believe. Yeah, so okay, 15 already does it for me. So then now we can play around with why 15 is wrong, right? So 15 we get 6 instead of 5. What is 15? There's some property that maybe I'm not observing, but we'll play around with this idea. So 15, I don't have anything immediate. 15, right? 1 to 5. So our strategy was to go 1, 2, 4, 8, and then 5. So this is 1, 2, 3 steps, and then from 8 to 5 is 3. So that's 6 in total. So how do we do it in 5? We go 1, 2, 4, minus 1 times 2 minus 1. So this is 1, 2, 3, 4, 5. So this is 5 steps, right? And just to write it out so it's less confusing. Huh. So okay, so our early hypothesis is wrong, and sometimes with greedy you are going to be wrong, or is I'm going to be wrong, and that's just how I was playing around with it. I mean, the only way that I know how to do it otherwise is doing some kind of dynamic programming thing. But that's given 10 to the ninth. That seems a little bit hard to do. You think about this. Well, this code is not going to be right, but So right now I'm just trying to see whether there's a way for me to figure out this pattern. So before I had a greedy, that hypothesis clearly is wrong, but I mean, we could also do a breadth first search, but that still feels like it reach way too many numbers. Like I think the the 1 to 1 billion had 39 steps, meaning that I guess actually we can do breadth first search. No, well, it has to get to a number that's bigger. Can you do breadth first search? I don't think so, because for 1 to 1 billion, I'm trying to do the math because I feel like I always do the math incorrectly before. So we go 1, and then you double, and then you double again, you go to 3. Yeah, you double 3 and 8. You go 2, which is done. You go 6, 7, 16. Right? And so I don't know. I don't think you can just do that. Right? Because this is going to have 5, 12. I mean, for every level, it's going to be doubling, right? Okay, I just am pretty sure about it. So, if this is going to be some like depth or like recursive search and bound, I'm going to be really sad. But and maybe I'm just a little tired. I don't really have an idea right now, other than that greedy. How do I do this? Dong dong dong. And maybe I could find another pattern that. Maybe 111. What's 111? Oh, I didn't change the thing. 35 to get to 11? Wow. Oh no, 35 is to this. 111 is 6, which, before we would have tried 1, 2, 4, 8, 16, 15, 14, 13, 12, 11. But instead, the answer is, this is like 8 or something. I didn't actually count, so I could be off by 1 on that one. 9. But the answer to get to 11 is actually 4, 8, 7, 6, 12, 11, maybe? Something like that. So maybe I do see a pattern now, which is actually funky, but so this is 6, right? Or my guess of the pattern is that no. Is it easier to, so I'm thinking about, is it easier to do this, or is it easier to do the opposite, which is increment and half, which is the same thing, right? Because double, we can keep on doubling, but half becomes easier because you can only half if it's an even number, right? Huh. Because now if you go from 11, you can go to, well, you have to take the 12 and then 6, but then what, 1 2, oh wait, no, wait, why didn't I go 3? 1 2 4 3 6 12 11. Is this 6? Oh, this is 7 actually, so I lied. But this assumes the answer is, I mean, the x is 1, which, you know, is not the case. Well, not always the case. What happens if it's another number? So we have, what was the example? 2 3. 2 to 3. So 3 can go to 4 and then divided by 2. So that's okay. That's just trivially done. 5 8. Let's try another one. 5 8. So 8 will have to go to 4 and then okay. That's also trivially done. Whoops. 3 10. 3 10. 10. We go to 5. We go to 6 to get 3. Okay. Okay, this is the other one that I was thinking of. 24 and 1. And then once this is smaller than this, we can only increment, right? Yeah, okay. Maybe that's, I don't know that I'm convinced, but let's play around with it. If x is equal to y, oh sorry, the other way around. If x is greater than y, then we can only decrement because there's no other way to make this smaller anyway. And this is also if they're equal, then this should be 0, right? Otherwise, while x is less than what? Yeah. But that's the same as what we had before, right? Maybe? Am I wrong? So 5. 1 to 5, right? So what's our strategy? 5 goes to the 6. 6 actually goes to so 5 6 actually goes to 3 in our greedy. 3 we go to 4 and then we go to 2 and then 1, right? Did I mess up? Oh no, I did that here, right? This is my old algorithm. Okay, but what about something like, I don't know, 3 10, say, right? So this is what I do actually a lot when I am stuck on a greedy-ish. I mean, I have a sense that this is greedy-ish. So then I will pay on papers most of the time and not live like this because, you know, but oh, this is actually one of the examples. Whoops. Let's see. Let's do 12, right? Well, 12 is even more obvious. Let's do co-primes, 17 and 11, right? So what's 17 to 11? So we 18, we go to 9, and then now this is just decrement by 2. Is that best? 11 to 17? 4. I'm trying. Like, I feel like I have an intuition here, but I can't really prove it. Just like I didn't prove the other ones, so I'm a little bit confused about it, and I'm not super confident about it. But let's code it up since this is okay. Oops. Plus x minus y, something like that. But this looks right. I probably, yeah, okay. But to be honest, even if this is right, I don't know how to prove it. Okay, let's give it a submit. I'm not gonna lie, okay, so this is right. Like I said, I'm not gonna lie, I don't know how to prove this one, because if I did, I would have done it more quicker. I suspect that they don't have this as a crazy difficulty. It's just that I don't know how to do it. I mean, and the reasoning is just going backwards. Let's see. Well, because I mean, I think my logic here and the reason how the way that I came up with this solution is because every step of the way you're forced to do something, right? Kind of. Because if y is odd, then you have to increment because there are no other moves, right? If y is even, that's the hard part that I don't know how to prove. Then we could divide it by 2. But how do we prove that that's optimal, right? Like, I mean, I know that that's a thing to do to get us. Okay, I see. Then we can divide it by 2. Because, I see. If y is greater than x, because the alternative to this is we increment twice and then divide by 2. But this will always be suboptimal, right? I don't know if this is obvious. I know that this is true, but you could just think about it, right? Like if x is greater than if y is greater than x, right? Then you have either, and y is even in this case, then you have either y over 2, which is, or y over 2 minus 1. Oh, sorry, yeah. No, y minus 2 plus 1. But in both these cases, this costs 2 extra moves, but we could have done it afterwards, right? Because we can get to y divided by 2 plus 1 by just, so there are 2 ways to get here, right? One way is doing, 2 ways to get here. First way is to do something like, like to just do it greedily, right? You do y divided by 2 plus 1. 2 moves. Second way is to do y plus 2 divided by 2, which is 3 moves, right? Is that, yeah, 1, 2, yeah. so we can see that first way is always better. So I guess I think that's what I mean by forced, is that once you do it that way, everything is, you're forced to do, like every move you're forced, because if you do something else it's suboptimal, because also if it's odd you have no choice. Yeah, and this is even that n is x minus y, because you keep on incrementing until, because there's no other way to get higher. So this is going to be your best move. Okay, so it's just greedy to that point, but I think the code is very, you could, it's up to you to decide whether this is easy, because this is just a while loop. But as you can see, there are a lot of kind of confusing things that goes into this problem. And hopefully, watching me struggle through it, and even trying a greedy algorithm incorrectly, give you some insight as to how I solve problem, and also taking into the problem, right? And even when I got it correctly, I'm trying to prove myself why this is correct. And while this isn't a rigorous proof, you can kind of see this logic, and hopefully that's good enough for you. If not, leave me a comment leave me a question or whatever in the comment and let me know. I hope that also the reverse of this problem, I think I hand waved over this a little bit, but this is the reverse of the problem. So instead of going from x to y, we went from y to x, and then the operations are, the opposite. We do it by 2 or add 1. So hopefully that makes sense. And then once we have that problem of going from y to x, we have these two decisions, which is not really a decision. One is if it's odd, we increment. If it's even, we either divide it by 2, because we all, this one you have no choice no matter what. But here, the only time you don't want to divide it by 2 is if x is greater than y, but we already returned here, so x will always be less than y. And in that case, to make y smaller, we always want to divide it by 2. And as we all said, they'll only, if we want to get to y over 2 plus 1, for example, it's always optimal to do it the first way. So yeah, that's all I have for this problem. If you stuck with me for this long, I hope this was good. I do hope you fast forward a little bit, or did fast forward, because there was a lot of struggle, but maybe that's interesting to you, and I hope it is. Cool. That's all I have for this problem, except for whenever I say that, I have to go look through, I have to do the complexity. So what is the one-time complexity of this? It's going to be log y, because we are only going to divide y by the number of digits. We do increment, but the increment will not add the number of digits, because you always only need to add 1 to get one more, to get an even number, which does this, right? So it is the number of digits, so it's going to be log y, which is actually linear, the size of the input, because the input is the number of bits. And of course, by that logic, you could also say that it takes linear space, because it takes the number of bits that's corresponding to the number of bits into the output. So linear time, linear space, if you want to call it that. Log y time, log y space, if you want to call it that. But it's not. But the key part here is that you have to be consistent with the time and the complexity and your analysis. And if you're able to transfer around them, then that's fine. You could even say this is all one time and all one space, because it takes at most 32 times 2 operations, so 64 operations, and obviously constant number of bits, because we have constant number of variables. That's all I have. Let me know what you think. Oh, actually, let me click on the solution. Let me see what their intended solution is. Because I wanted to learn real quick. Work backwards. Okay, that's basically what I did. Is that it? Okay. Yeah, how does one come up with such a condensed answer? But this code is basically the same as mine. You just have to kind of think about it in a good way. And it turns out that why is my thing reset? But yeah, so I guess that is the intended solution. And looking at my code, it is true that I actually didn't need this part, because you could have just put it, because this while loop took care of it, but that's fine. Cool. But I feel like my code is clean-ish as well. Let me know if you agree. Let me know if you're not. Let me keep it open. I don't know why it went away. That's pretty weird, actually. I didn't delete it, did I? But yeah. While I wait for the code to come up, there we go. Thanks for hanging out. I'll talk to you later. Join me on Discord. Take care of yourself, take care of others, stay good, stay well, stay healthy, and to good mental health. And I will see you tomorrow. Bye-bye.